All right, 6.1, part 2. All right, so if you remember all the way back in geometry, when you were proving triangles congruent, and you had the angle-side angle theorem, side angle side theorem, and in geometry you said that you could not use a side-side angle theorem to prove that triangles were congruent. And the reason, usually the way that we talk about it in geometry, is we say that there's possibly more than one triangle that has two given sides and an angle. So we don't get we're not absolutely certain that we only have one triangle. That's why we couldn't use a side-side angle theorem to prove that triangles are congruent. Well, we can use the law of sines on side-side angle triangles. We just have to make sure that we are careful with what kind of triangle we have. So I'm going to talk about, for this first part, we're going to say angle A is acute. We have three possibilities for a triangle that's a side-side angle triangle. So this puts a little twist on the law of sines. So our first possibility, and I'm going to draw the triangle. I always draw my law of sines triangles that look like this. So we're given angle A. So this angle can't change. These two, this segment and this segment, can't get closer together. And we're going to say angle B, if there is an angle B, is down here. This would be angle C. This is going to be side A, and this is side B. So this angle can't change. We're given angle A, we're given side B and side A. So we have a side-side angle triangle. My first possibility, A is less than B. And, let me draw this in here. We used this when we talked about the law of sines. There's the height of the triangle. A is also less than the height. So my triangle looks something like this. Is that a triangle? There's one on the left side, but the height is not really part of our problem. We just calculated that. So yes?
How is this different than those problems on the homework? What's different from those ones?
Those problems were either angle side angle or side angle side triangles.
But those two have two sides.
The ones that I gave you last night that were two sides and an angle were not. They only give one triangle, so they weren't ambiguous case triangles. So today we're going to have to figure out if we do have an ambiguous case. So what was different with those is they were set up so that they would work.
Okay.
So the ones you get tonight are not always set up so that they only work one way. So if A is smaller than B and A is smaller than H, we have no triangle possible. And thinking about how we set up our law of sines yesterday, how we showed that it worked, how do we find the height of this triangle if we know angle A and we know side B? H equals, we said B sine A. So if we have a side-side angle triangle and A is less than B, we need to figure out, is A also less than the height? If A is less than B and A is less than the height, then we have no possible triangle. So that's one case with a side-side angle triangle. Yes?
We know that the angle A is for sure.
We are given angle A, so that cannot change. So this angle here doesn't change. So we can't bring this side up here closer. This has to stay exactly like it is. and I should say, this should say angle A. So we're given angle A, we're given side B, and we're given side A. So this can't change. All right, our second possibility is if A equals H. So then my triangle looks like this. And this is A, this is A, this is B. What kind of triangle would this be if A equals H? We get a right triangle. And there's only one possible triangle. So if A is exactly equal to the height, and we know that the height here is B sine A, if A is exactly equal to the height, we have one possible triangle for a side-side angle triangle. And then our third possibility. That's when things start getting interesting with our third possibility. So I'm going to draw my generic triangle like this. And we're going to say this is A, this is B, C. I'm going to draw in my height. And this is B, and this is A. In this case, A is less than B, but A is greater than the height. In this case, what I can do, and what I usually explain to my geometry students, is if I think of this point up here being on a pivot, I can swing the side around and it can connect over there on this side to make another, it's going really slow, another triangle. That looks like this. And this is still side A. That's still the same length. And we have two possible angle B's, two possible side C's. One that corresponds to this angle and one that corresponds to this angle. So we have two triangles. This possibility where we have two triangles is called the ambiguous case, because we don't know, is it one of the triangles, is it the other triangle? So we have to use the law of sines to figure out both. So we have two angle B's, and we have two angle C's, and we have two side C's. So one of these angle B's we can figure out with the law of sines. We just use our law of sines. What do we know about this angle and that angle, since those two sides are the same? They are congruent. What do we know about these two angles? Supplementary. If you subtract one from 180, you get the other one. So the two possible angle B's are supplementary. So we would use the law of sines, just like we've done before, just like we did on problem 13 and problem 19 there. Use law of sines to find angle B. That would let us find angle C, and then we could find side C. We find the other possible angle B by subtracting the original one we got from 180. That would give us this angle B. We would use that angle B to find the other possible angle C. and then we could use a law of signs to find the other sides. So this is what we call the ambiguous case, because we end up with two possible triangles. And as always, H equals B sine A. So on all of these, the key to all of these is figuring out the height of our triangle, and then looking at how A relates to B and how A relates to the height. If A is too small, we can't make a triangle at all. If A is exactly right, we can make one right triangle. And if A is somewhere in between, we can make two possible triangles. So with a side-side angle triangle, we have to decide which of these possibilities we have. So on number 13 and number 19, we were only asking for one possible angle, so we didn't have to worry about it. The ones today, we're going to ask to find all the possibilities for a triangle. All right, questions before we go on? Let's look at, so these were our three possibilities if A is acute. If A is obtuse, it's much easier. So we have the first situation, if A is obtuse, we have something that looks like this. There's A, there's B, and here is angle B if it exists. If A is less than B, can we make a triangle at all? No, this angle can't change. So if A is less than B for an obtuse angle A, we have no triangle. And then the other possibility, let's move that. So there's my obtuse angle A, there's side A, there's side B, and there's angle B. A is greater than B, so we have a situation like this. There's only one possible triangle. I can't rearrange these sides to make a different triangle if this angle is A and this side is B. So we only have one triangle. So if A is obtuse, either the triangle doesn't exist or we have one triangle and we just use a law of signs like we normally have. All right, we good there? So what I want to do is go through a couple of examples looking at how we decide which case we have. So we have a side-side angle triangle. And then right at the very end, we get to learn a new formula for the area of a triangle. We get two new formulas for area of a triangle in this unit. It's kind of nice. All right, so let's look at some examples. First one. So we have angle A is 26 degrees. B is 5 feet. And I'm just going to say 5. And side A is 21. So on all of these, what I'm going to suggest on all these possibilities, I'm going to go back and put this here. You want to draw a picture. So if we have a side-side, always draw a picture. We always want to calculate our height. And for obtuse angles, we don't have to worry about it. There's only two possibilities. We want to find H. And depending on A, B, and H, we decide which case we have. And then we use a law of signs. If we have the ambiguous case, we have to use the law of signs twice and calculate our sides and our angles for two different triangles. So that's what we're going to do on pretty much all law of signs problems. We don't always have to decide which case we have, but drawing a picture is always helpful. All right, so here's my picture for my generic law of sines. And I'm not going to connect these sides because we're not 100% sure that they work. So that's 26 degrees, this is 21, and this is 5. And this would be angle B. That's how I always like to draw these. Okay. All right, so let's think about this one. A is larger than B. A is greater than B. Now, in order to make a triangle, how does A have to compare to the height? It has to be bigger than the height. If A is smaller than the height, then it won't connect. But this side is 5, and our angle is 26 degrees. Sine of 26 degrees is between what and what? Our sine function goes at the top, it's how big? 1, and at the bottom it's -1. So the sine of 26 degrees is somewhere between 0 and 1. We multiply 5 by that number. Are we going to get a number bigger than 5 or smaller than 5? Smaller than 5. So our height, if we calculate our height, we know our height has to be less than 5. So how does A compare to the height? Bigger, right? If the height is 5 sine 26 degrees, sine of 26 is between 0 and 1, so when we multiply this by a number between 0 and 1, I get a number smaller than 5. So if I calculate it, the height comes out to be 2.19. So A is bigger than the height. A is bigger than B, A is bigger than the height. We have one triangle. So it connects up here, something like this. So there's only one possibility. If I tried to swing this around to connect to the other side here, because it's bigger than B, it would miss. Swing out over here, it would miss. So it can't connect it in any other way. So we can just set up, if this problem said find angle B, we could set up the law of sines. We'd say sine B over 5 equals sine 26 degrees over 21. So sine B is 5 sine 26 over 21. And I plug in my calculator, I would say B is the inverse sine of this whole thing. Plug that in my calculator. You can plug it in just like this as long as you're in degree mode, and I would get that the B is about 5.99 degrees. And then if the problem asked me to, if it said solve the triangle, I could then find angle C, and I could find side C. Yes? If A equals H, then we have a right triangle. If A is bigger than B and A is greater than H, there's only one possible triangle. So I guess we could go back, if we go here, we could say we could add here to this one A greater than B and A greater than H. Gives us one triangle. So on this one, if we needed to calculate C, we could do that just like we did with the law of sines yesterday. All right. So questions there. Okay. Let's look at another example. let's say B for this one is 78 degrees, and C is 12, and B is 5. We want to find angle C. So let's draw a picture. Here's my generic law of sines triangle. I don't know if this side connects yet, so I'm not going to connect it. This is 78 degrees. This is 5. And this is 12. And this would be angle C down here if we have a triangle. So here we have B is less than C. What do we need to be true in order to make a triangle here? How does this have to compare to the height? This piece has to be larger or smaller than the height? Larger. If it's smaller than the height, then it looks just like this, and we can't connect. So we need 5 to be bigger than the height. So let's find the height. Our height equals the height equals 12 sine 78 degrees. And I plug this into my calculator, I get height equals 11.7. So this height is 11.7. So can this side length of 5 connect down here to this base down here? No, it's too short. B is less than C, and B is less than the height. The height is 11.7, so we have no triangle. So this is impossible. You don't have a triangle that works like this. The side is too short. Now if you didn't find your height, if you just went and started calculating with law of sines, we would say sine C over 12 equals sine 78 over 5. And this tells me that sine C is 12 sine 78 over 5. So C is the inverse sine of 12 sine 78 over 5. Anybody have a calculator out? Plug that in your calculator and see what happens. What does it tell you? Error. So if I plug this in my calculator, I get an error. That's a hint that you have a triangle that doesn't exist. You have no triangle. And we figure that out by, what's that?
Is that always true?
If the triangle is impossible and you try to plug those numbers into your calculator is going to give you an error. Because you're trying to take the inverse sine of something that's bigger than 1. No angle has a sine that's bigger than 1. And we figure that out by calculating the height and saying, oh, that side's too short to connect down here to this side. The height's too big. It'll never reach. All right, questions there? Okay. Let's look at another one. So for this one, A is 29 degrees. Side A is 6, and side B is 10. We want to find angle B. So here's my generic law of sines drawing. There's 29 degrees. This side's 6. This side is 10. This would be angle B down here. All right. So from our drawing, we know that A is less than B. In order to have a triangle, how does A, how does this side have to compare to the height? How does this side have to compare to the height if we're going to make a triangle?
It's too bigger.
Has to be bigger. So let's find the height. The height equals 10 sine 29. So if we think like we did on that first problem, sine of 29 has to be between 0 and 1. So I still could get something that's bigger than 6, or I could get something that's smaller than 6. So we can't decide right away. So when I calculate this in my calculator, the height is 10 sine 29. So my height equals, when I calculate this, I get 4.85. Well, A is less than B, and A is bigger than the height. That tells us we have two triangles. So we have the situation where we could have one triangle like so. And I'm going to put my height in there. This is 6, this is 10, this is 26 degrees. So we have one triangle like this, or we could swing this side around and connect over here. So we could have one triangle that looks like this. So we have both of these possibilities for angle B. We use law of sines to find one of them. So let's just plug into the law of sines. We know we have to find two. So I'm going to say sine B over 10 equals sine 26 over 6. So sine B is 10 sine 26 over 6. And B is the inverse sine of this thing. I plug that in my calculator, and it tells me that B is about 53.9 degrees. So this angle is 53.9 degrees. That's one possible angle B for this ambiguous case. The other possible angle B, our other B, is 180 minus 53.9 degrees. And when I calculate that out, I get about 126.1 degrees. And this angle here would be 126.1 degrees. So those are the two possibilities for angle B. If we needed to find side C, so this side down here would be side C, we would have to find the two possible angle C's. Once we have angle B, we could find angle C. And then we could use the law of sines, again, to find side C for each of these two possible triangles. So we got the ambiguous case here because A was less than B, but A was larger than the height. So I can connect somewhere over here, and I can swing that side around and connect somewhere over here. So when we have this two possible triangles, we call that the ambiguous case. Because we don't know if we're talking about one or the other. All right, questions there? Okay. So as you might guess, on the homework tonight, they will give you side-side angle triangles. And all the triangles that we just worked with were side-side angle. We had two sides and one angle. That tells you might have to worry about the ambiguous case. So then you calculate your height, decide which case you have, and go from there. All right, the last thing for today. Area of an oblique triangle. So we talked about this we've talked about it multiple times today, finding the height of our triangle. We talked about it when we talked about why the law of sines works. Yes.
Hi, can we have a Chris Scott for us for 5 minutes?
Chris is not here today.
Okay, thank you.
All right, so here is the height of our triangle. We've calculated it a bunch of times today. We used it when we talked about why the law of sines works. What is the area of this triangle? What's our general formula for the area? I'm going to write it as 1/2 the base times the height. We know how to find the height if we know this angle. We said that the height was b sine A. So if I say this is the height, what's the base of this triangle? How long is the base? C, right? So the area is 1/2 BC sine A. So if I know two sides and the angle between, I can figure out the area of the triangle. I could do the same calculation with the height drawn from any of the other two vertices, and I would come up with a similar formula. AB sine C and 1/2 AC sine B. So all of these come from drawing our height from a different vertex and plugging that into the formula for the area of a triangle. So we have a new formula for finding the area of a triangle if we know two sides and the angle between them. Nice easy formula to use. Nice easy formula to calculate. Yes. Little c. So this is side c. And this would be a big C. So I guess I could make that C. So we're talking about the side lengths here. So if we had a triangle, for example, that had B equals 143 degrees, A equals 7, and C equals 18, the area equals 1/2 7 times 18 times the sine of 143 degrees. Plug that in my calculator and calculate, and I get about 37.91 units squared.
So you do say like 7 times 18 first, that.
It doesn't really matter. Since we're multiplying them all, we can do it in any order and multiply in any order. All right, questions? Okay. Tomorrow we'll talk about law of cosines. There we go.